Welcome to a video on trig integrals involving secant and tangent, and this is part 1. All of the techniques discussed in this video are based on the Pythagorean identity tangent squared theta plus 1 is equal to secant squared theta, or solve for tangent squared theta would give us tangent squared theta equals secant squared theta minus 1. Let's go and take a look at the first case. If the power of secant is even, we're going to save a secant squared factor and then convert the remaining factors to tangent. So again, if the power of secant is even, we'll save one factor of secant squared, and then the remaining factors of secant squared will be converted to 1 plus tangent squareds. Once we do that, if we let u equal tangent x, then differential u will equal secant squared x dx. So in this form we'll have 1 plus u squared to the k minus 1 power times u to the nth power, and then secant squared x dx is equal to du. So then we'll expand this integrand and then integrate with respect to u. Let's go ahead and give it a try. The first step is to rewrite this, saving a factor of secant squared. So we're going to save this factor of secant squared and convert this factor to tangent squared x plus 1. So then we'd have tangent squared x times tangent squared x plus 1 times secant squared x dx. So we still have this extra factor of secant squared x, but if we let u equal tangent x, then differential u will equal secant squared x dx. So all of this would be equal to du, and over here we'd have u squared times u squared plus 1. Let's go ahead and rewrite this integral in terms of u. So if we distribute here, we'll have u to the 4th plus u squared du. So now we'll integrate this with respect to u, and then rewrite it in terms of tangent x. So we'd have u to the 5th over 5 plus u to the 3rd over 3 plus c, and then since u is equal tangent x, we'll have 1/5 tangent to the 5th x plus 1/3 tangent to the 3rd x, and then plus c. Okay, the next case is when the power of tangent is odd, and when this is the case, we're going to save a secant tangent factor and then convert the remaining factors to secants. So if our integrand has factors of secant and odd factors of tangent, we're going to save one factor of secant and one factor of tangent. So notice the secant to the power of m will become secant to the power of m minus 1, and then an extra factor of secant. And then given this odd power of tangent, we'll save one factor of tangent here, leaving an even factor of tangents here. So again, the result was we saved a factor of secant x tangent x. And then we'll convert these tangent squared x's to secant squareds minus 1. Once everything is in terms of secant except for this extra factor of secant x tangent x, we'll let u equal secant x, therefore differential u will equal secant x tangent x dx. So all of this will be du, and all this will now be in terms of u. Let's go ahead and give it a try. So since the power of tangent is odd, we want to save a factor of secant x tangent x. So we'd have tangent to the 4th x, secant to the 2nd x, and the extra factor of secant x tangent x. Again, this is the factor that we wanted to save. Now we're going to convert tangent to the 4th to secants. Well, we know that tangent squared is equal to secant squared minus 1, but we have tangent to the 4th. So this will end up being the quantity secant squared x minus 1 to the 2nd power times secant squared x times secant x tangent x. Now that everything's in terms of secant except for this extra factor here, we'll let u equal secant x. Therefore, differential u is equal to secant x tangent x. So all of this now becomes du, This becomes u squared minus 1 to the second, and this is u squared. So let's go ahead and rewrite this in terms of u. Again, this is going to be u squared minus 1 squared, so it'll be u to the fourth minus 2u to the second plus 1 times u squared times du. Let's go ahead and distribute the u squared. So I have u to the sixth minus 2u to the fourth plus u squared, all with respect to u. Now we'll find the antiderivative in terms of u. So I have u to the seventh over 7 minus 2 times u to the fifth over 5 plus u to the third over 3 plus c. The last step is to rewrite this, replacing u with secant x. So we'll have 1/7 secant to the 7th x minus 2/5 secant to the 5th x plus 1/3 secant to the 3rd x, and then plus c. Let's go ahead and take a look at one more case for this video. So for this last case, if there are no secant factors and the power of the tangent is even and positive, we'll convert a tangent squared factor to a secant squared minus 1 factor, and then repeat this if necessary. So again, if we have an even power of tangent with no secants, we're going to save a tangent squared and then replace that with secant squared x minus 1. Let's look at an example of this. So we'll save a tangent squared factor, now we're going to replace this tangent squared x with secant squared x minus 1. Let's go ahead and distribute this tangent squared x and see what happens. Let's rewrite this as two different integrals. And notice this first integral we have an even factor of tangent squared x and an even factor of secant squared x. But if we let u equal tangent x, then differential u would equal secant squared x. So now we can just use basic u substitution. But on the second integral, notice this second integral fits the same case that we just dealt with. We have an even power of tangent, so we're going to go ahead and replace this tangent squared again with secant squared x minus 1. So now I think we're in pretty good shape. Taking a look at this first integral, this would be u squared, and all this would be du. So the antiderivative of u squared would be u to the third divided by 3, or 1/3 u to the third, and again u is tangent x, so we'd have 1/3 tangent cubed x minus the antiderivative of secant squared x would be tangent x. That's a basic antiderivative. And then the antiderivative of 1 would be x, so we have minus negative x, or plus x, plus c. Okay, that's going to do it for this video. In part 2, we'll take a look at some additional examples. I hope you found this helpful.